Good day, students. This is topic 1, lesson 5, and we are now continuing on to translations. Okay, so some of the learning targets that we're going to have today is how to represent translations in a coordinate plane, how to describe those translations as functions, whether we're given the inputs or outputs of that particular translation, and then also the definition of translations in terms of parallel lines and line segments. But before we do so, we have to look at exactly what questions we should be asking ourselves throughout this lesson. So how can a translation of a polygon be described as a function of inputs and outputs? Well, they give us this function rule for translations here, and this function rule determines how we move our pre-image and image within that coordinate plane. So our A in this function rule tells us that there's some type of horizontal shift along the x-axis, so whether that figure is going to move to the left or right, a certain amount of units. And then we have B, which is representing our vertical shift along our y-axis, and that tells us how many units up or down that we're going to move. And we're also going to use what we call vectors, and those vectors pretty much gives us the idea of what direction and how many units we're going to be moving that figure along A and B. The second question we have to look at is how can we use the definition of translations in terms of parallel lines and line segments, and how that's used to translate a figure. So if we're given a certain pre-image, we can link line segments from one vertex of that polygon to another, and that tells us that these corresponding parts or vertices here, these corresponding vertices that are being linked, the segments that it creates, are creating congruent and parallel segments so that we know that every time we do a translation, we are doing some type of slide that creates line segments that are congruent and parallel. All right, so let's jump right into example number 1. It says draw the image of triangle ABC after a translation along vector V. So triangle ABC here is what we will call our pre-image. So I'm labeling this so we can distinguish our pre-image from our image. And it says along vector B. So if we remember in our warm-up activity, a vector has an initial point, which is our starting point, and it has a terminal point, which is our end point. To determine our translation and how we move it or how we slide it, we have to count the horizontal and vertical shift or units of our vector. So here our vector tells us that we're moving 1, 2, 3, 4, 5 units to the left. So if we're moving 5 units to the left, that's a -5. And then we're moving 1, 2 units down. Okay, so that means that we're going to do that for every point in our pre-image to get the points of our image, the vertices of our image. So let's start with A. From A, we're going to move 1, 2, 3, 4, 5 units to the left, and then 1, 2 units down. So A prime is going to now be here. Next, we're going to do the same for B. We're moving 1, 2, 3, 4, 5 units to the left, and then 1, 2 units down. So we have B prime here. And then the same thing for C, 1, 2, 3, 4, 5 units to the left, and then 1, 2 units down. So we have C prime here. Now that we have all three of our vertices, we could go ahead and connect them to create our image. And I'm going to label that I. And here we go, guys. We see that we have taken our pre-image of triangle ABC using our vector to slide it in the direction that was given, 5 units to the left and 2 units down. Okay, so example 2 says, consider the transformation function x comma y, which is being transformed using the function x plus 2 and y minus 5. Part A says the function translates the points x, y, 2 units in what direction, and then 5 units in what direction. So remember, if I'm looking at this function, the function tells us that x represents our A, remember, and our A tells us how many units we're moving horizontally. So that's determined also by the sign that's given. So because the sign is positive, I know I'm moving 2 units to the right, okay? And then remember, our y represents our B, and that's how many units we are shifting vertically. So if I'm shifting 5 units and this is given by a negative, that means I'm shifting 5 units down. Okay? Part B says, what is the algebraic description for a transformation that translates the points x, comma, y 2 units to the left and 3 units up? So 2 units to the left, 2 units to the left. So that means that I take my points and I'm going to use a function where 2 units to the left tells me that I am going in the opposite direction of right. So I'm going to the left, and that's going to be -2. And then 3 units upward tells me I'm going vertically on my y-axis, and if I'm going up, I'm doing a +3. So that would be my function rule for that translation, moving 2 units to the left and 3 units up. Part C says, what is the algebraic description for a transformation that translates the points x, comma, y 3 units to the right and 2 units down? So remember, 3 units to the right, I'm going to take my points, and if I'm going 3 units to the right, that is a horizontal shift, so that's along my x-axis, and to the right is going to be a +3, and then 2 units down, that is a vertical shift, so that means I'm moving along my y-axis, and if I'm going down, that's going to be -2. Okay, so example 3 says transform triangle ABC according to the function rule where we have x added to 3 and y being subtracted by 2. And we're going to write the coordinates for the triangle A prime, B prime, C prime. So let's first look at the rule that's been given to us. They tell us that our horizontal shift is going in a positive direction. So if I know I'm going in a positive direction, that means I'm going to the right. 3 units. And then my vertical shift tells me I'm going in the negative direction along my y-axis. So that means I'm going 2 units down. So before we write the coordinates, let's just go ahead and shift all of my points from my pre-image, remember that's my pre-image, to create my image. So we're going to start with point A. So A tells me I'm going 3 units to the right, so that's 1, 2, 3, and 2 units down, 1, 2. So my new point, A prime, is there. Same thing with B. I'm going 3 units to the right, 1, 2, 3, 2 units down, 1, 2. So my new point for B, B prime, is there. Next, I'm doing C, so we're going to do 3 units to the right, 1, 2, 3, and 2 units down, 1, 2. So my new point for C is there, and that is C prime. Okay. So now let's go ahead and connect our vertices, and that's going to create our now image. Okay. Now they want us to write the coordinate points of triangle A prime, B prime, C prime. So for A prime, I have my coordinates at -6, 2. So that's -6, 2. At B prime, I have my points at 1, 2, 1, 2. And then at C prime, I have my points at 1, 6, 1, 6. And there we go. That's for example 3. Okay, so example 4 tells us that we have a segment AP, and it undergoes a translation such that A prime is 1, 1, and P prime is 4, 3. And they want us to find the values of A and B. So remember, when we have a translation, that function rule creates a new image where we had some type of horizontal shift, and we call that horizontal shift A, and we had a vertical shift, and we call that vertical shift B. All right, so they want us to find the values of A and B. So let's go ahead and first plot the points for our image. Remember, this is our pre-image, and then this is here, A prime, P prime is our image. So we have 1, 1, 1, 1 is here for our A prime, and then P prime we have 4, 3, which is here. And that's our P prime. Okay, and we're going to go ahead and connect those two. So I have my pre-image and I have my image. And we're going to determine what the A is first. So for the A, remember A is a horizontal shift, right? Horizontal shift. How many units do I have to move in order to get to that image point? So let's go from A and see how many points lands me to A prime. So we have 1, 2, 3, 4, 5, 6, 7. So far it looks like we have 7 points, 7 units, and we went to the right, so we know that is 7 units plus, right? And then let's see how many units we had to move vertically to get to A prime. So we had to move 1, 2, 3, 4 units, and that was 4 units down. 4 units down. So I know that if I wanted to write the rule for this, I can write that my rule is to go 7 positive units to the right, and then we're going negative 4 units down along my y-axis. Now it says, which of the following statements is true? So we have 4 statements that's stated here about the pre-image point and the image, the pre-image segment and the image segment. So they're first of all asking us if the pre-image and the image have different locations, if the pre-image and image have different shapes, if the pre-image and image have different sizes, or if the pre-image and image have different directions. And we have to determine which one is true. Well, let's see. Let's think about this. If I look at segment AP compared to segment A prime P prime, I can determine that the size and shape did not change, right? So there's 2 I could already eliminate. I can eliminate this first, the second one, and the third one. The size and shape stayed the same. Let's look at the direction. So the direction of segment AP and the direction of segment A prime P prime also did not change. There was no rotation, there was no flip or turn. So we can say that we can eliminate that one. So the only one I see that's true is that there is a different location. The location did change, okay? And that's exactly what happens with a transformation when you have a translation. When you slide a figure in a coordinate plane, it does change the location of that figure. Okay, in our last example, example 5, they give us polygon A prime, M prime, O prime, R prime, E prime, S prime. And this is the image of polygon AMORES after translation of 8 units horizontally to the right along the x-axis and 7 units vertically down along the y-axis. They want to know what are the original coordinate points of point M of the polygon AMORES. So here they've given us the image point of our figure here. This is our image, and they've given us the image point M prime. So M prime here, looking at our figure, is 4, -2. Now, if I'm trying to find the pre-image point given the image point, there's a little rule that we can say. We can take the image point, and that's only given a translation. We take the image point and we subtract it by the rule, and that gives us our pre-image point. And remember, that rule consists of x and y coordinates. So let's go ahead and apply that rule. So my x coordinate for my image is 4, right? And remember, our rule states that our horizontal shift is 8, so I'm going to subtract that by my rule, and I get -4. So I know that my pre-image point for M is going to be -4. And then we're going to do the same thing for Y. Y is -2 in our image point, and remember, we're going to subtract that by what we have here in the rule, which is -7 for our Y. So remember, we have a negative and a negative, so that gives us a positive. So I have -2 plus 5, -2 plus 7, I'm thinking ahead of myself, equals 5. So that means the y coordinate of our pre-image point for M is -4, 5. So let's go ahead and graph that on the coordinate plane. So -4 is 1, 2, 3, 4 to the left, and then 1, 2, 3, 4, 5 units up. So that tells me my point M for my pre-image is here. Now we want to check to make sure that the rule still works and that this is indeed our point. So our rule told us that we're going to the right 8 units. So that's already in the right direction because right now our image is to the right. So let's see, we have 1, 2, 3, 4, 5, 6, 7, 8. So far, so good. 8 units to the right. And then we're supposed to go 7 units down. So let's see, 1, 2, 3, 4, 5, 6, 7. 7 units down. So indeed, we can say that the image point that led us back to our pre-image point is in fact -4, 5. All right, guys, so now that we've finished the class notes, it is your responsibility to make sure that your warm-up activity is done. So that warm-up activity can be found in your class notebook in OneNote, and that has all the vocabulary for this lesson, lesson 5, for translations. I will see you in class, and have a wonderful day, guys.